Section 4.5, the graph of tangent. Our essential question today is to figure out what the graph of y equals tangent of x looks like. So a couple of things first. Tangent has some vertical asymptotes, and we can use a unit circle to explain that. If I had an angle of 90 degrees, tangent is the y value divided by the x value on the unit circle. So the tangent at 90 degrees, or in radians, pi over 2 radians, is equal to 1 over 0, which is an undefined number. So I can't find the tangent of pi over 2. It's undefined. I can find the tangent of something super close to pi over 2, right? So I could find the tangent of this angle. Now that tangent, it'd be the y value over the x value, and you notice the y value is going to be pretty close to 1, and the x value is going to be pretty small. In fact, I could even get closer, and then the y value is even closer to 1, and the x value is even smaller. If I have a value that is really close to 1, like 0.999, and I divide by something super small, like 0.1, well, that's going to get bigger and bigger and bigger. The closer this gets to 1 and the closer that gets to 0, the bigger my function is going to get. Now, one way to see that is if I take something like, well, let's just put a number, let's just put a 1. If I divide by 1 by 0.1, that's 10. Divide 1 by 0.01, that's 100. Divide by 1 by 0.001, that's 1,000. And we can hopefully see that the closer my denominator gets to 0, the bigger my value gets. So I'm going to have a vertical asymptote because the closer and closer and closer I get to an angle of pi over 2, the closer the denominator is going to get to 0, which means pi over 2 is going to go up towards infinity. So when I graph this thing, as I get closer and closer to pi over 2, there's going to be a vertical asymptote. My angle is going to get closer and closer to infinity. All right. Interesting enough, tangent also has a different period than sine and cosine. Tangent has a period of pi, and we can use the unit circle to explain that too. So tangent has a period of pi because the values repeat when I do the opposite, when I do the y divided by the x. So like when I do 1/2 divided by square root of 3 over 2, well, that's going to be the exact same as a negative 1/2 divided by negative square root of 3 over 2. These functions on the opposite sides are going to provide the same tangent. So when I find tangents, as I go around this unit circle, all the tangents on one side of that are going to be the same as the tangents on the other. That tangent will be the same as the tangent there. The tangent there is going to be the same as the tangent there. And so the values actually repeat themselves every pi units. All right, so we're going to graph tangent of x. When we do this graph, we're actually going to do it in a kind of a strange way. We're actually going to start it at negative pi over 2 and end it at pi over 2. The reason we're going to do that is because that's where my asymptotes are, right? I'm going to be dividing by 0 at pi over 2. And I'm also going to be dividing by 0 over here, which I'm going to go the opposite direction, which would be a negative pi over 2. So I've got an asymptote here and there. Now we already said on the one side, as I get closer and closer to pi over 2, I'm going to go towards infinity. So let's work backwards from there. All right, so we're going to work backwards. I already know the tangent of pi over 2 is undefined. But the closer I get to that, the closer I'm going to go towards infinity. That's why I've got this vertical asymptote. However, let's put in some other values. What about tangent of pi over 4? Well, that's a y divided by x. Square root of 2 over 2 divided by square root of 2 over 2. Anything divided by itself is 1. So I'm going to put in here at pi over 4. I've got a value of 1 right there. Let's try to find a few more. What about tangent of 0? The tangent of 0 would be y divided by x. That's 0 divided by 1. That's 0. All right, so tangent of 0 is 0. This is going to go down to there. All right, let's keep going. What about tangent of negative pi over 4? Right, negative because I'm going downward. Tangent of negative pi over 4. Well, that's negative square root of 2 over 2 divided by square root of 2 over 2. That's going to be negative 1. So this is going to continue at negative pi over 4 right there. And then I'm getting towards this undefined value at negative pi over 2. That's going to be another asymptote. But this time, instead of going up towards infinity, it's going down towards negative infinity, because negative 1 divided by something super small is going to get super big in the negative direction. It's going to go towards negative infinity. So that's one full period of tangent. We mentioned again that tangent has a period of pi. From here to here is pi units. So that's one full period. So when we graph tangent, it just repeats like that over and over and over again. It'll do like that again with another asymptote over here. On this side, it'll look like that with another asymptote over here. Every pi units it repeats. That's what tangent of x looks like. All right, some important characteristics to remember about tangent. First of all, it has a period of pi, not 2 pi, so watch out for that. Second, remember that the asymptotes are at negative pi over 2 and pi over 2. So right here and right here, you've got vertical asymptotes. And then other than that, just remember that it divides evenly into 4 parts. You'll have an asymptote, and then a value of negative 1, right at that negative pi over 4, right halfway between there and 0. Then a value of 0, then a value of 1 again. And then it's just going to repeat with an asymptote and keep going. Value of negative 1, halfway between the 0 and the asymptote. Value of 1, halfway between the 0 and the other asymptote, then an asymptote, and those values just keep repeating. All right, let's give one an actual try here. Graph the tangent of 1/4 x. All right, well, the period of tangent is normally pi, but because that 1/4 is there, I'm going to multiply the period by the reciprocal, 4 of 1, and I get a new period of 4 pi. So that means when I graph my tangent, I already know what it looks like. It looks like this. It's got a couple of asymptotes. But this time, I want the period, I want that distance to be a total of distance of 4 pi, which means on one side, I'm going to have this be 2 pi at that asymptote, and this other asymptote would have to be negative 2 pi. So it has a distant total period of 4 pi. That's all there is to it. If I want to be a little bit more accurate, right here halfway between pi, that value should be a value of 1, so I might as well put that there. And halfway between there at negative pi, that value should be negative 1. Graphed. All right. Your assignment today is worksheet 4.5.0. The 0.0 is because it's just on tangents. We normally would do cosecants and secants and cotangents in this class, but with distance learning, we're just going to do tangents. Give that a try, and I will see you guys later.